Solar-powered parking lot control gates represent a viable alternative to traditional AC-powered systems, especially when AC power is inaccessible or cost-prohibitive to install. They are frequently found in remote parking areas or completely off-grid locations. Solar-powered gates operate by converting sunlight into electricity using solar panels. This electricity powers the gate motor and other operational components. Solar panels are often installed on top of the gate structure or on a nearby pole. The advantages of using solar-powered parking lot control gates are numerous. Firstly, they offer cost savings. Solar-powered gates eliminate the need for AC power, thus reducing your electricity expenses. Secondly, they are environmentally responsible. These gates generate no emissions, contributing to a smaller carbon footprint. Thirdly, installation and maintenance are simplified. Solar panel installation is typically straightforward, and the gate's components generally require minimal maintenance. When considering solar-powered parking lot control gates, it's important to understand the key components and considerations for optimal performance. Firstly, the solar panel wattage must be properly sized. The solar panel array must be able to generate sufficient electricity to power the gate's motor and any auxiliary devices, such as card readers or intercoms. Proper sizing ensures reliable operation, even during periods of low sunlight. Secondly, the battery capacity is crucial. A battery bank stores the energy generated by the solar panels, providing power to the gate when sunlight is unavailable. The battery capacity should be large enough to accommodate the gate's usage patterns and local weather conditions, ensuring continuous operation. Thirdly, the gate motor should be energy efficient. Select a gate motor that is designed for low energy consumption. This will maximize the efficiency of the solar power system and extend the battery life. Fourthly, the controller is important. The controller manages the charging and discharging of the batteries, preventing overcharging and deep discharging, which can damage the batteries. A good controller also provides status monitoring and diagnostic information. Fifthly, consider the local climate. The amount of sunlight available will affect the performance of the solar power system. In areas with frequent cloud cover, a larger solar panel array and battery bank may be necessary. Sixthly, maintenance is a key consideration. Regularly inspect the solar panels for dirt and debris and clean them as needed. Check the battery terminals for corrosion and replace the batteries as needed. Also, inspect the gate motor and other components for wear and tear, and lubricate them as needed. Seventhly, consider security features. Implement appropriate security measures such as access control systems, surveillance cameras, and alarms to protect the gate and the parking lot. Eighthly, research local regulations. Check with your local authorities to ensure that your solar-powered parking lot control gate complies with all applicable regulations. Ninthly, professional installation may be warranted. Although installation is typically straightforward, consider hiring a qualified installer to ensure that the system is installed correctly and safely. Tenthly, understand wireless communication considerations. For wireless card swipe systems, ensure reliable communication between the card readers and the gate controller. Consider factors such as range, interference, and security when selecting a wireless system. Common problems encountered with solar-powered parking lot control gates often relate to insufficient power, battery issues, or communication failures. Insufficient power can be addressed by increasing the solar panel wattage or battery capacity. Battery problems can be avoided by using high-quality batteries and regularly maintaining them. Communication failures can be resolved by improving the wireless signal strength or using a different communication technology. Regarding wireless communication options for card swipes, several technologies are available. Firstly, radio frequency identification, or RFID, is a common choice. RFID technology uses radio waves to identify and track tags attached to objects. In the context of parking gates, RFID tags can be embedded in cards or key fobs, allowing authorized users to open the gate by simply presenting their tag to a reader. RFID systems are relatively inexpensive and easy to install, but their range is limited to a few feet. Secondly, Bluetooth Low Energy, or BLE, offers another option. BLE is a wireless technology designed for low-power communication. BLE-enabled card readers can communicate with smartphones or other devices, allowing users to open the gate using a mobile app. BLE has a longer range than RFID, typically up to 30 feet, and it offers enhanced security features. Thirdly, cellular communication provides a wide-area solution. Cellular-based card readers can connect to the internet via cellular network, allowing users to open the gate from anywhere with cellular coverage. Cellular communication is more expensive than RFID or BLE, but it offers the greatest range and flexibility. Choosing the right wireless technology depends on your specific needs and budget. Consider factors such as range, security, cost, and ease of installation when making your decision. Power calculations for a solar-powered gate involve several factors. Firstly, determine the gate's power consumption. This includes the wattage of the motor, any auxiliary devices, and the controller. Secondly, calculate the daily energy requirement. Multiply the power consumption by the number of hours the gate operates each day. Thirdly, estimate the solar panel output. This depends on the size of the solar panel array, the amount of sunlight available, and the efficiency of the solar panels. Fourthly, calculate the battery capacity. The battery capacity should be large enough to store enough energy to power the gate for several days without sunlight. Fifthly, factor in the system losses. Account for losses due to wiring, inverters, and other components. To illustrate, let's assume a gate motor consumes 100 watts and operates for 10 hours per day. The daily energy requirement is 100 watts times 10 hours equals 1000 watt-hours. If the solar panels generate 500 watt-hours per day, you will need a battery capacity of at least 500 watt-hours to provide backup power for one day. However, it is always recommended to have a battery capacity that will cover at least 2 or 3 days with no sun. The National Electrical Code, or NEC, provides guidance on the safe installation of solar power systems. NEC Article 690 covers solar photovoltaic systems. Some relevant sections include 690.4, which addresses general requirements, 690.8, which covers circuit sizing and current, 690.9, which deals with overcurrent protection, 690.31, which covers methods of grounding, and 690.71, which pertains to battery storage. It is crucial to adhere to the NEC requirements to ensure a safe and compliant installation. In addition to the NEC, local building codes may also apply. Check with your local authorities to determine the specific requirements for solar power systems in your area. These codes may cover aspects such as permitting, inspections, and setbacks. When selecting a solar-powered parking lot control gate, it's also important to consider the materials used in its construction. Gates made from durable materials such as steel or aluminum will withstand the elements and resist corrosion. Also, look for gates with powder-coated finishes for added protection. Consider the gate's design and aesthetics. Choose a gate that complements the surrounding environment and provides a professional appearance. Also, ensure that the gate is easy to operate and maintain. Regarding manufacturers of solar-powered parking lot control gates, several reputable companies offer high-quality product. Consider exploring options from FOC, Came, BFT, NICE, and High Security. Each company offers a range of gate systems with different features and specifications. Research their products and compare them to your specific requirement. In conclusion, solar-powered parking lot control gates provide a compelling solution for access control, especially when AC power is unavailable or expensive to install. By carefully considering the components, power requirements, and installation guidelines, you can implement a reliable and cost-effective solar-powered gate system. These systems offer environmental benefits and long-term cost savings, making them a sustainable choice for parking lot management.